Alright, sorry. So we will continue on our previous example. So we are trying to find the value of P Z less than negative 0.85. Okay, if you see my previous example, we have drawn the graph for z less than negative 0.85, and we want to find the value of the probability. Alright, so let's have a look at the normal table again. Okay, so if you see at the normal table, there are two normal tables. One which gives you the z value, which is a negative 1, and 2, it would give you a value that is a positive 1. Okay, so we are referring to the negative 1, and we want to find the value of z negative 0.85. So if I zoom in, you can see that negative 0.8 is here, and then we are moving row wise and looking at the value under 0.05. So you can see that this is the value that we are looking for, 0.1977. So the value of Pz less than negative 0.85 would be 0.1977. Here, 1977. 0.1977. Okay? Okay, so this is the probability that we are looking for. Okay, now let's have a look at an example that we have on the slide. You can refer to your slides. Okay, this one is z greater than 1.2915. Okay, so you know that 1.2915 is a positive value, which is on the right hand side, and because this is greater than, so it means that you are looking at the area on the right hand side. Okay, so this is the area that we want. Okay, so let me open my page here. Okay, there is one okay, there is one property of normal distribution the probability of z greater than 1.2915 is equal to the probability of z less than negative 1.2915. Okay, now if I draw the graph of both, okay, so this is our normal graph and this is our 0, right? So 1.2915 would be here. 1.2915. Okay, and z value greater than 1.2915 would mean that we want this area here. So this is what we want in our question. Now, because if you refer back to your normal table, you are given this one, which gives you the negative value of z, and you are given this one. It gives you the big area here, the left hand side, and a positive value of z. So when you know that z greater than 1.295 is also equals to z less than negative 1.2915, so the graph would be something like this. The distance between 0 and negative 1.2915, sorry, it's 2915, is the same as the distance from 0 to here. So in this case, less than would be the left hand side. So this means that this area would be equivalent to this area. So we just have to find z less than negative 1.2915 by referring to okay, wait. Okay, by referring to the first graph, so we want to find negative 1.2915. So negative 1.2 is here, and then 915. So negative 1.290. So we just round it off to 2 decimal points. So it's negative 1.29 only. So here a negative 1.2 is here, and 9 would be the last column here. Negative 1.29. Okay? So it's 0.0985. So this is equivalent to 0.0985. So what does this mean? This means that this area is 0.0985. This area also is 0.0985 because it is equivalent in terms of the value. Alright? Okay, so if you go back to your slide here, it gives you negative 0.0983, because this one this is the exact value, but it's okay, you just have to give this value. Okay, this is also correct because the difference is very small, and because it depends on the table that you are using. Because we are using this table, and this table would be provided during the exam, so you just follow this value here. Alright? Okay. Now let's have a look at this question. A population is normally distributed with a mean of 100 and variance of 400. What is the probability that a value selected randomly from the population will have a value greater than 130? Okay, now in this case, so let's have a new one. Okay, you have a mean value of 100, so it means that your mu equals to 100. Standard deviation is equals to 400. Oh, sorry, square root of 400. Okay, because this is variance, we don't want variance, we want the standard deviation. And then you want to find the probability of what? The probability of a value greater than 130. So this is x first. X greater than 130. Okay, so this is equals to P Z greater than 130. This is your x, so you follow the formula to convert it into z, minus your mu divided with your standard deviation. It's 400. Okay, so if you try to calculate this, so you will get P of Z greater than, okay, let's have a look at this. Square root of 400 is, okay, so we can directly use this. 130 minus 100, 130 minus 100 divided with square root of 400. Okay, 1.5. Okay, so PZ greater than 1.5. Okay, now if we sketch the graph of it, so this is a graph and this is 0. So 1.5 is somewhere here. So it's the area, the small area that we want. So it means that it's equivalent to the negative of it also. So if you look at your graph, you look at your table, so you can refer to this table here, but you refer to the negative 1.5. So negative 1.5, negative 1.5 is negative 1.50. So you are referring to this one. So negative 1.5 is 0.0668, 0.0668. This is the probability for this. Okay, so let's have a look at the answers here. Oh, there's no answers. Okay, so this is the first one. Okay, so the probability that a value selected randomly from the population will have a value greater than 130, it will be equivalent to 0.0668. Okay, now let's have a look at this one. What will happen to the probability if we change the variance to 2 to 5? If we change the variance to 2 to 5, so it means that here it has to be 2 to 5. So let's rub this off. So instead of having a variance of 400, it is having a variance of 2 to 5. Okay, so here also we need to change it to 2 to 5.